Assalamu alaikum. Today we are going to study the first condition of equilibrium. This condition helps us to understand when a body is said to be in translational equilibrium. In simple words, translational equilibrium means that a body is not accelerating. It may be at rest or it may be moving with a constant speed in a straight line. To understand this properly, we will begin with the basic law of motion. यहाँ पे हम न्यूटन के लॉ की हेल्प लेंगे to explain this state of equilibrium. According to Newton's second law of motion, the force acting on a body is equal to the mass of the body multiplied by its acceleration. This law is written as F is equal to ma. Now, if body is in translational equilibrium, its acceleration is 0. So we can write now A is equal to 0. If acceleration is 0, then from the equation F is equal to ma, the force acting on the body must also be 0. This leads us to the first condition of equilibrium. Before writing the condition, we must understand a symbol used in physics. This symbol is called sigma. Sigma means sum or total. It tells us that we must add all the quantities together. ये सिग्मा का सिंबल अक्सर हम टोटल समेशन के लिए भी इस्तेमाल करते हैं. The first condition of equilibrium states that a body is in translational equilibrium only if the vector sum of all external forces acting on it becomes 0. Mathematically, we can write sigma F is equal to 0. इसको इस तरह से पढ़ा जा सकता है sigma F equals to 0 or the sum of all the forces is equal to 0. The word vector is important here because force has both magnitude and direction. Vector sum means that we add forces by considering their directions. If two forces act in opposite directions and equal in magnitude, they cancel each other. As a result, the total force becomes 0 and the body remains in equilibrium. इसका मतलब है दोनों फोर्सेस एक दूसरे को कैंसल आउट कर देंगी. In many situations, forces act in different directions. To check equilibrium, we resolve these forces into horizontal and vertical components. For translational equilibrium, the sum of forces along x-axis must be 0. The sum of forces along y-axis must also be 0. This means that sigma F is equal to 0, sum of forces along x direction is 0, sigma Fy is equal to 0 means sum of forces along y direction is also 0. Now consider a body pulled the right by a force with 20 newtons. Now supply another force of 20 newton to pull it on the left hand direction. Because these forces are equal and opposite, their vector sum is also 0. So the body will be in translational equilibrium as both the forces are cancelled out by each other. Now consider a book resting on the table. The book has weight acting downward due to gravity. The table exerts an upward force called normal reaction. If these two forces are equal, the sum of vertical forces also becomes equal to 0. So sigma Fy is equal to 0. This means that book is in translational equilibrium also. A body in translational equilibrium is not necessarily at rest. It can also move with a constant velocity. The key condition is that the body has no acceleration. Let us summarize today's lesson. The first condition of equilibrium we study today is that a body is said to be in translational equilibrium if the vector sum of all the external forces acting on it becomes zero. Mathematically, sigma f is equal to 0, sigma fx is equal to 0, or sigma fy is equal to 0. This is known as the first condition of equilibrium.